Alright, so I've redrawn my circuit. I've decided to ignore the capacitor and the diode in order to predict or to analyze what the conditions of the circuit are providing as far as voltage between points A and B and between points C and D. Now particularly I'm interested in what the diode is going to see, because the capacitor will charge to whatever is available to it, and if that value changes, it will discharge to, again, whatever is available to it. Now that diode, once it sees the conditions of the circuit, if the conditions are met in which it will bias in one way or the other, its voltage will be held to that value. So the voltage between C and D will be determined by that diode. And so if the diode does react and start to allow current flow and to bias, it will change the rest of the circuit. And so the big thing that I need to figure out is that C to D voltage, and then decide what the diode's going to do. So that being said, I can, for now, I can kind of forget about all that and just look at what's in front of me. And so I can see I just have essentially a series circuit, but with two power supplies in it. And so I can create a loop equation and figure out the net voltage, and then I can create I can solve for that current in that series circuit, and then I can find all the voltage drops in those resistors. So let's do that. So first I'm gonna look at polarities. Okay, so the symbol of these power supplies tells us that the polarities are just like that. Now if you notice, if I look at the polarity from the V1 or the 20 volt supply, and I'll just draw in those polarities on my resistors, plus, I'm just looking from the 20 volt supply for now, plus minus, plus minus. Alright, now notice, even though this 16 volt supply is drawn upside down with the negative up, the polarities on the resistors are aiding. So it turns out that the batteries 20 volts and 16 volts are series aiding, so that voltage is just going to combine on each resistance and not do any canceling or anything like that. So just to go over that again, the 20 volt supply provides polarities plus minus, plus minus, plus minus, right? And then if I look at the 16 volt supply going backwards on R3, minus plus, minus plus, minus plus. So it is the same for both supplies. So I'm just going to draw a quick Kirchhoff voltage loop equation just to see how this goes. So Kirchhoff says, and I'll just start here in my traditional bottom left hand corner, go clockwise as I always do. So Kirchhoff says 0 volts in any closed loop equals the sum of all voltages around that loop. Okay, so let's just look at what all that might look like. So I'm just going to go from this point clockwise, and I will end on that point. So I know I see a negative 20 volts known voltage and polarity, and I see R1 plus VR1 plus VR2 plus VR3 minus 16 volts plus VR4 plus VR5. Now of course I've run out of room here. Plus, let me just fix this just a little bit real quickly. Plus VR6. Alright, let's see if I can actually just move that here. And I think I can. There we go. Bear with me for the scrolling. Sorry about that. Alright, but anyway, there's my rough loop equation. Now, I mean, that's all interesting, but what I can essentially get from that is that 20 volts plus 16 volts equals the sum of all those resistors. So VR1 plus VR2 plus VR3 plus VR4 plus VR5 plus VR6. Alright, so that looks to be what, 36 volts. So 36 volts equals all of those. Okay, VR1 plus, this is going to be redundant, but let's just do it, plus VR3 plus VR4 plus VR5 plus VR6. Now, some of you might already have done it or have been thinking about doing this. We've got basically voltages equal voltages. So what I really want is voltages equal, resistance times current, so that I can start expanding and manipulating my algebra just to make my my current, because ultimately what I'm solving for is current, but I haven't written anything down about current. So we've already covered some, in the previous sections we've covered mesh. So we'll use kind of, now like I said, I mix and match my different theorems just to make my, whatever I'm dealing with easier. So I pick my favorite pieces of different theorems. And had I been thinking about this using just mesh analysis going into it, I may have, said I loop or whatever times the sum of my resistors, right? So I times R1, I times R2, and so on and so forth, basically just factors out to I times the sum of all those resistors. Alright, so there's all my resistors. Whoops, that's going to be a 6, so let's fix that so it's more clear. Okay, so I've got 6 resistors, okay, and ultimately what I'm solving for is current, just this outer current, this intermediate step of whatever this current in this series configuration would be. So I'm going to say that current equals 36 volts, which is the combined sum of those power supplies, over the sum of all those resistors. Now I could say RT, so let's just do that, or R sum. Okay, let's fix this little line here. Alright, so I need to solve that value, so IT equals, let's just go ahead and bring in the calculator and find that. So I equals 36 volts over what the sum of all those are. So let's just find out what those are right now. So let's see, bring in the old calculator. We just got to get all the things in the right spot. Alright, come on calculator, where are you? There you are. So let's see, 110 R1 plus 130 for R2 plus another 110 for R3 plus 150 for R4 plus 220, 220 for R5 plus 750 for R6. And so that gives me, provided I plugged everything in properly, the 6 resistors, 1.47K. 1.47K ohms. Alright. Okay, so let's bring the calculator back because I actually have to do the solving now. Okay, so calculator. Alright, so I've got my 36 volts, so clear 36 divided by my resistance that I found is going to be a current of 24.49 milliamps. Okay, so this isn't the final current in this circuit, but without the diode and without the capacitor, this is the current that would be flowing. So you could build this and actually see that and measure it. Okay, so let's see. So just to be sure, I wrote that down properly, 24.49 milliamps. Okay, so let's figure out what that C to D voltage is. So the first thing I need to do is solve all of my resistors voltages. So let's just do that. Alright, so I've got all my voltages solved. So I'm going to, now at this point I need to analyze the circuit so I can figure out what my C to D voltage is from C to D. So the way that I typically will do that is I'm going to imagine myself putting my voltmeter right there with the black lead on D and the red lead, not the black lead, so the red lead right here on point C. So my meter, if I do that, will show me a positive number if VCD is positive and a negative number if VCD is negative. And I use that as a stand-in because I don't know the polarity yet, so I will just use my meter leads as a stand-in, and then the result will come in either negative or positive, and that will tell me what my voltage is. Okay, so I'm going to fill in my voltages, and then I'm going to create a loop equation for this loop here to solve for my unknown voltage, and then I'll verify it using the other loop, and just to make sure that they come out with the same result, which they should.